So welcome to this latest video on 162 Maths. In this video we'll be going over the AQA Level 2 Further Maths Past Paper of June 2022, Paper 1, which is a non-calculator paper. Now before we get started working through this test paper, a little reminder that I'll include a question breakdown in the description below. So if you find any questions challenging, you can see what topic it relates to and then probably go back and revise that topic. And I'll also include a link to the 162 Maths contents page, which gives you easy access to lessons and other further maths walkthroughs. So starting on question 1, it says x plus 1 is increased by 20%. Its value is now the same as x plus 6. Work out the value of x. Well, looking at the first bit of information, to increase anything by 20%, we need to multiply by 1.2. So what we've got is 1.2 multiplied by x plus 1, and that gives me the answer of x plus 6. So if we expand the brackets, we get 1.2x plus 1.2 equals x plus 6, and then we just solve this equation. So we'll end up with 1.2x minus x equals 6 minus 1.2. This will leave me with 0.2x, and this will leave me with 4.8. So x is going to equal 4.8 divided by 0.2, which is equivalent to 48 divided by 2, which gives me an answer of 24. So x equals 24. Then moving on to question 2, it says the point minus 6 minus 4 lies on a straight line with a gradient of 3, 2. Work out the coordinate of the point where the line crosses the y-axis. So for this, what we need to do first is we first of all need to work out what the equation of the line is going to be. Now for this, I'll use y equals y minus y1 equals x minus x1. You could do a different way, but as long as you get the right answer, then that's going to be fine. So for this, we're going to end up with y plus 4, because minus minus 4 becomes plus 4, equals m, which is 3 over 2, and minus minus 6 becomes plus 6. So then from this, we know that it crosses the y-axis when x equals 0. So all I need to do is substitute x equals 0 into this. Now you may decide to simplify and write it as in the form of y as the subject of the equation of a line, but it's not necessary. So here we're going to end up with y plus 4 equals 3 over 2, and 0 plus 6 is just 6. So from this, what we end up with is y plus 4 equals 18 over 2, and then y plus 4 equals 9, so y is going to equal 5. So the answer to this is going to be 0, 5. Moving on to question 3a, it says that f of x, and we've got our multiple function here, or composite function here. Now for this, what we want to do is we want to plot each of these particular sections. Now looking at the range, our first range is from 0 to 1, so that's going to go from here, and the two x values we've got are 0 and 1. So if I substitute x equals 0, I'm going to end up with 4 minus 0, which is 4, so that's going to be there, and 4 minus 1, which is 3, and that's going to be there. And all I need to do is with a ruler draw a line through those 2 points there. Then for the second section, that goes from 1 to 4. And so here we've got the equation of 4x minus 4x squared. So we're going to end up with, and I've got the range of 1 to 4. Like so. So here if I substitute 1 into that, I'm going to end up with 4, 1 minus 1 squared. And that's going to give me an answer of 3. 4 times 2 minus 2 squared. And that's going to give me 4. 4 times 3 minus 3 squared, so that's 12 minus 9, which is going to give me 3, and 4 times 4 minus 4 squared is going to give me 16 minus 16, which is 0. So what that then becomes is 3, and then at 2 it's at 4, and at 3 it's going to be at 3, and at 4 it's going to be at 0. Now this is going to be a quadratic function, so this is going to look something like that. And then for the last section, we've got the values of 4 and 6. So it's going to be 2 times 4 minus 8, which is 0, and 2 times 5 minus 8, which is 2, and 2 times 6 minus 8, which is 4. So it's going to be 0 and 2 and 4. And then just draw a line with a ruler from there. So what my final answer will look like is it will look like a straight line, then part of a parabola, and then a straight line like so. Moving on to question 3b, it says g of x is equal to 6 minus 3x, and work out the inverse function of x. So to work out the inverse function, the first thing we do is make it equal to y. And then what we then want to do is make x a subject. So if I do y plus 3x equals 6, then 3x equals 6 minus y, and then x equals 6 minus y, all divided by 3. So that gives me an answer of g inverse of g. X is going to be 6 minus x over 3, or I could write it as 2 minus x over 3. So any of those two ways would be absolutely fine. Moving on to question 4a, it says circle the value of tan 30 squared. Now tan 30, well, tan squared 30 is the same as tan 30 all squared. Now tan 30 is an x-value trig that you should know, and tan 30 is 1 over root 3. So then this is going to be tan squared 30 is going to be equal to 1 over root 3 squared. 1 squared is 1, and root 3 squared is 3. So the one I want to circle is the second option. Moving on to 4b, it says sketch on the axes y equals cos x. So for here, we need to have a point at 1. What you should have is this should be a much neater curve, and it should be there. So this should be at 0, this should be at 1, this should be at 0, and this should be at 1. And there we go. Moving on to question 5, it says work out the values of a and b. So this question we need to compare the coefficients. So if I first of all expand this out, so here I'm going to end up with 3x times 5x, which is 15x squared. 3x times minus 4 is minus 12x. Then end up with plus 5ax and minus 4a. And that is equivalent to 15x squared minus 2x plus b. So now what I need to do is compare the coefficients. So the coefficients of x squared. Well, I've got 15 on the left hand side, and on the right hand side I've got 15, so that's not a problem. Pretty pointless for me doing that actually. Then we look at the coefficients of x, in which we've got minus 12 plus 5a equals minus 2. So solving this, we end up with 5a equals 10, so a equals 2. And then if we look at the constants, we've got minus 4, well, let's write down the constant. So the coef of the constant is we've got minus 4a on the left hand side, and we've got b on this side. Now we know that a equals 2, so that's going to be minus 8 equals b, and there is our answer. So a is 2 and b is minus 8. Moving on to question 6, differentiation. It says y equals, and we've got our expression. We want to work out the values of dy of dx. Now for this, what we need to do is expand the brackets. So I've got y equals, and then if I just multiply out the bracket, I end up with 2x to the power of 7, because we add the powers, plus 4x to the power of 4 minus, and then 2 times 3, which is 6, x to the power of 4 over x. Now from this I can then simplify, so this x cancels with the 4 to turn it into a 3, so y equals 2x to the power of 7 plus 4x to the power of 4 minus 6x cubed. And this is where I can now differentiate. So to differentiate, we lower the power by 1 and move the power to the front, lower power by 1. So that's going to be 14x to the power of 6 plus 16x to the power of 3 minus 18x squared. And that there is my answer for that. Oh, should be a minus. 18x squared. There we go. So moving on to question 7, it says ABC is a right angle triangle with vertices A minus 1, 5, B minus 2, 5, and C minus 1, 5 and 3/4. And the question is asking us to work out the length of BC. Now to work out the distance between two coordinates, we need to use the formula of D equals, and it's x2 minus x1 squared plus y2 minus y1 squared. And the coordinates that we're using for BC, this is going to be my x1, this is going to be my y1, this is going to be my x2, and this value here will be y2. So substitute those numbers into this formula here, then what we end up with is D equals square root of 5 3/4 minus 5 squared minus minus 1 minus minus 2 squared. And simplifying that, what we end up with is D equals, and it's going to be 3/4 squared minus, sorry, that should be a plus 1 squared, or square rooted, and so that means D is going to equal 9/16 plus 1. Now because it's non-calculated, we want to convert that 1 so it's easier for us to add that fraction up. So that's going to be 9/16 plus 16/16, which gives me an answer of 25/16. And square root of 25 is 5, square root of 16 is 4. So the distance between BC is 5/4. Now you can write that either as a fraction or you can write it as a decimal. So you can write as 1.25, whichever floats your boat. Moving on to question 8, it says use matrix multiplication to show that in the xy plane a rotation of 90 degrees anticlockwise about the origin followed by a reflection in the line y equals x is equivalent to a reflection in the x-axis. Now for this particular question, what we need to do is recognize what the matrix is for each of these three things. So a reflection in y equals x is going to look like 0, 1, 1, 0. A rotation anticlockwise 90 degrees is going to look like 0, minus 1, 1, 0. And a reflection in the x-axis is going to look like 1, 0, 0, minus 1. So from this, what we need to do is multiply these two things together. So what we end up with is 0, 1, 1, 0 multiplied by 0, minus 1, 1, 0. And then we need to work that out. Now from this, what you then do the matrix multiplication, in which you will end up with 1, 0, 0, minus 1. And you can see here that these two things are the same. Moving on to question 9, it says a quadratic sequence starts -2, -1, 4, 13. Work out the expression for the nth term. So for this, what we need to do first is find the double difference. So we've got -2, -1, 4 and 13. And difference in here is 1. And then difference here is 5. Let me just correct that. Is 5. And then we've got a jump of 9. And then the double difference is 4. So that means that 2n squared is going to be in the formula. So from this, we've got n, we've got 1, 2, 3, 4. We've got the numbers in the sequence, which are -2, -1, 4 and 13. And then we've got 2n squared. So if I write these squared values, we've got 1, 4, 9 and 16. And that's going to give me 2, 8, 18 and 32. And then what I then want to do is look at the difference. So the difference between this to this is going to be minus 4. Here to here is minus 9. Here to here is minus 14. And here to here is minus 19. So then the nth term for the diff is going to be minus 5n plus 1. So the nth term is going to be joining these two things here, in which, again, nth term of 2n squared minus 5n plus 1. Now moving on to question 9b, it says a different quadratic sequence has an nth term of n squared plus 10n. Use an algebraic method to work out how many terms in the sequence are less than 2000. You do not use trial improvement. So for this, what we need to do is we make the nth term plus 10n, and it's got to be less than 2000, and so we end up with something that looks like this. Then from this, what we then want to do is treat it like a quadratic. So we take the 2000 over to the other side. And then from this, what we now need to do is solve for this. Now, this does factorize, in which we get n minus 40 n plus 50, in which then, again, n value of 40 or minus 50, n can't be negative, so the answer is 40. And then because we want, she's not 40, now because we want to show that it's less than 2000, we actually need to take one away. So we take away 1 from 40, giving us an answer of 39. Moving on to question 10, it says rationalise and simplify fully root 3 over 3 plus root 3. So for this, what we need to do is write out the question, and then to rationalise it, we need to multiply it by 3 minus root 3. So then what that then becomes is it becomes root 3 bracket 3 minus root 3 over 3 plus root 3, 3 minus root 3. This then becomes 3 root 3 minus 3 over, and that's going to be 9 minus 3. And then simplifying that, we get 3 root 3 minus 3 over 6. And then I can cancel a 3 out, or divide everything by 3. So that becomes a 2. That becomes nothing, a 1. And that becomes a 1, leaving me with an answer of root 3 minus 1 over 2. Now moving on to question 11, it says expand and simplify fully 3 plus 2x to the power of 5. Now you could go as long as doing the multiplication with brackets, but it's not recommended. This is a binomial expansion question. Now with binomial expansion questions, you end up with a Pascal's number. You end up with the first term, and you end up with a second term. And looking at Pascal's triangle, we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, and 1. Now the line that we want is going to be the 6th row, which is these numbers here. So Pascal's number is going to be 1, 5, 10, 10, 5, and 1. Now in terms of the first term, which is 3, now the first term always starts high and ends low. So that would be 3 to the power of 5, 3 to the power of 4, 3 to the power of 3, 3 squared, 3 to the power of 1, and 0. And the second term, let me just move that up a little bit so we've got a bit more room for the final answer. This one is 2x, and this one starts low and ends high. Let me just get rid of that, made a mistake there. Like so. Now in terms of these, 3 to the power of 5 is 243. This is 81. This is 27. This is 9. this is 3, and this is 1. 2 to the power of 0 is just 1. That's 2x. That's going to be 4x squared. That's going to be 8x cubed. That's going to be 16x to the power of 4. That should be. Let me just correct that. And then we've got 32 to the power of 5. Then all that's left for me to then do is multiply these three things to get our expansion. In which then, if we have, and if I just get rid of Pascal's triangle, just so I've got a bit more room. So this is going to become 1 times 243 times 1. This is going to be 5 times 81 times 2x. This is going to be 10 times 27 times 4x squared. This is going to be 10 times 9 times 8x cubed. This is going to be 5 times 3 times 16x4. And the final one is going to be 1 times 1 times 32x5. And again, let me just correct that. There we go. And so expanding all of that and simplifying it, we should end up with a final answer of 243 plus 810 to power to x plus 1080x squared plus 720x cubed plus 240x4 plus 32x5. And there is my final answer. Moving on to question 12, it says the nth term of a sequence is 3n squared over n squared plus 2. One term in the sequence is 32 over 11. Work out the value of n. So for this, what we need to do is just make the nth term equal to the term. So we've got 3n squared over n squared plus 2 equals 32 over 11. Now from this, if I do a bit of cross multiplying, I end up with 33n squared plus 32 actually equals, not plus, equals, and that's going to be 32n squared plus 64. Now as you can see here, this is slowly starting to turn like a quadratic, but it's not going to be a quadratic because we can then simplify. So if I take this over, I get 33n squared minus 32n squared equals 64. I'm then left with 1n squared equals 64. So n equals plus or minus 8. As n is a position of a sequence, the answer can only be positive 8. Moving on to question 12, it says write down the limiting value of the sequence as n tends to infinity. And for this, if I look at the original nth term, which was 3n squared plus 2, that as n tends to infinity, the numerator will become infinity, or 3 infinity. The bottom is just going to become infinity, and then for the infinities cancel out, leaving me with just an answer of 3. Moving on to question 13, it says simplify fully, and we've got this expression here. So what we need to do then is just simplify. So from this, I'm going to write this as 6x cubed y minus 2 plus 9x to the 5y divided by 3x squared y to the minus 3. Now I'm going to leave the y's alone, but I'm going to deal with the numbers. So I can notice that all the numbers are multiples of 3. So I divide by 3, so that's going to be a 1, that's going to be a 2, and that's going to be a 3. The smallest power of x is 2, so I take away 2 x's from both sides, so that's going to eliminate. That's just going to turn to a single x, and that'll turn to a 3. So what I've left with is 2x y to the minus 2 plus 3x cubed y over y to the minus 3. Now here what we want to do is we want to take out the lowest value of y. So then if I look at this, what we can then do is simply add 3 to each of the powers of y. So this then becomes, so add 3 to each power of y. So that then becomes y to the power of 0, and that's just 1. That turns into just a single y, and that is going to turn to the power of 4. So my final answer will look like 2x y plus 3x cubed to the power of y to the power of 4. And there we go. Moving on to question 14, it says rearrange EF equals 5e minus 4 over 3 to make E the subject. So for this, let's take the 3 over to the other side first, so we get rid of the fractions. That becomes 3EF equals 5e plus 4. Then we want everything with an e on one side, so we've got 3EF minus 5e equals 4. We can then factorise with respect to e, so we end up with 3f minus 5 equals 4, and then take the bracket over to the other side, leave me with e equals 4 divided by 3f minus 5. Moving on to question 15, it says B, C and D are points on a circle with centre P. A, B and AC are tangents to the circle, and the question is asking us to prove that y equals 90 plus x over 2. Now, as A and B and AC are tangents, it means that the radius meets a tangent at 90 degrees. So that means that this angle here is going to be equal to 180 minus x. Now from this, what we then know is that this angle here is going to be 360 minus 180 minus x. And if I simplify that, I get 180 plus x. So this angle here is 180 plus x. Now looking at the shape of BDCP, that is an arrowhead. So what I then have is that this angle here is going to be half the size of this angle here. So that means that y is equal to, or y, shall I say 2y is equal to 180 plus x. And then if I divide that by 2, half of 180 is 90, and half of x is x over 2, which is what they wanted me to prove. Now moving on to question 16, it says solve the simultaneous equations of x minus y equals 19 over 4, xy equals minus 3, and we can't use child improvement. So for this, first thing you want to do is make one letter the subject in this equation here. So I'm going to go for making x a subject, and what we end up with is y plus 19 over 4. Substituting that into this, what we end up with is y lots of y plus 19 over 4 equals minus 3. And then let me just make that 3 a little bit neater. Then if we expand the brackets, we end up with y squared plus 19y over 4 equals minus 3. Multiply everything by 4, and we get 4y squared plus 19y equals minus 12, leaving us with a quadratic of 4y squared plus 19 squared plus 12 equals 0. Now, as this is on a non-calculated paper, this does actually factorise, in which what we end up with is we end up with 4y plus 3 and 4y plus 16 equals 0. Now from this we get a y value of minus 3/4 or minus 4, and then from this we can then work out what our respective x values are going to be. So from this, what we can then do is, using xy equals minus 3, we end up with, when y is minus 3/4, we end up with minus 3x over 4 equals minus 3. So minus 3x equals minus 12. So x equals 4. So that's one set of values. And then for my second set of values, when x equals minus 4, when y equals minus 4, I should say, minus 4, we end up with minus 4x equals minus 3. So x equals 3 over 4. And there is my second set of results. So all that's left for me to do is just neaten up the answer. So x equals 3 over 4, y equals minus 4, and x equals 4, and y equals minus 3/4. And there are my set of answers. Then moving on to question 17, it says the point P lies on the circle of x squared plus y squared equals 16. The line OP has an angle of 60 degrees to the positive x-axis. Show that the coordinates of P are at 2, 2 root 3. Now for this question, as we've got here, we know that the radius is going to be 4. So looking at this triangle, what we've got is this length here is 4. Now looking at the coordinates of this, we've got 60, and this is what we're wanting to know. So what this distance here is. So using trig, we've got the adjacent and the hypotenuse, so we're going to be using cos. So cos 60 equals, and it's going to be x over root 4. Now cos 60 as an exact value of trig is a half, so that's going to be a half equals x over 4. And then doing a bit of cross multiplying, we get 2x equals 4, so x equals 2. Then if we look at the y ordinate, so let's say we want to work this out, then what we end up with is using sine. We get sine y, or sine 60 I should say. Sine 60 equals y over 4. I don't know why I've wrote root 4, so let me just go back and correct that. And then sine 60 as an exact value of trig gives me a value of root 3 over 2. So that's root 3 over 2 equals y over 4. Doing a cross multiplying again, we get 4 root 3 equals 2y. And then divide both sides by 2. We end up with 2 root 3 equals y. So therefore P is at 2 root 3. I'm sure there's probably a quicker way of doing it, but that's the route that made sense to me. Moving on to 17b, it says work out the equation of the tangent at P. Write your answer in the form of x plus ay equals b. So to work out the gradient of the tangent, so the first thing we need to establish is that the gradient of the tangent, or the gradient of the normal, is going to be, so it's, the normal is this line here. So we want to work out the gradient of that purple line. Now if you know that this is at 2 and this point here is 2 root 3, then the gradient is the distance going up, which is 2 root 3 over 2. So that's going to be root 3. So that means that the gradient of the tangent, which is the negative reciprocal, is going to be minus 1 over root 3. So that's my m value. Now we know that the coordinate is 2 root 3. So this is my x1 value. This is my y1 value. So therefore using y minus y1 equals mx minus x1. Substitute numbers in, we get y minus 2 root 3 equals minus 1 over root 3 x minus 2. And all that's left for me to do is then just neaten this up. Now from this, what I could do is just get rid of this fraction. So if I multiply everything by root 3, I end up with y root 3 minus, and then 2 times root 9 is going to be 6, equals minus 1 x minus 2. So that becomes y root 3 minus 6 equals minus x plus 2. Now we want to get x positive, so we take it to this side. So we get x plus y root 3, take the 6 over to the other side, and that equals 8. And there is my equation of the tangent. Moving on to question 18, it says in the triangle RST, RS to ST is in the ratio of 1 to 4. Work out the exact value of sine theta. Now, in terms of this, although sine of 135, now if we look at the sine graph, that sine of, so this is 90, sine of 135 is the same as sine 45. So sine 135 equals sine 45, and we know that the sine 45 is an exact value of trig, and sine 45, if I do some recollection, is 1 over root 2. So sine 135 equals 1 over root 2, or you can write it as root 2 over 2, whichever floats your boat. So looking at this, what we then got is we also know that RS is, so if RS is x, then ST is going to be 4x. So from this, what we can then do is we can use the sine rule to work this out. So we got sine, or should we say the side of that, so x over sine theta is equal to 4x over, and it's going to be sine of 45. Now we know what sine 45 is. That's going to be written as, and again you can choose whichever you prefer, so I want to go for 1 over root 2, and then with this we've got 4x divided by 1 over root 2. Flip the second fraction, so that becomes a times, and so what this all becomes here, the bottom denominator, or this whole fraction here, oh, let's not do that, so let me just get that back, is that here. So all of this is going to be equal to 4x root 2. So these two things here are equal. So if I just go down, so I've got a bit more space. So I've got x over sine theta equals 4x root 2. And then I can take the sine theta over to this side, so I end up with x equals sine theta 4x root 2. Then take the bracket over to the side, so I end up with x over 4x root 2 equals sine theta. Cancel the x's, so that's left with 1. That's there. And so sine theta equals 1 over 4 root 2. Now, if you did use 2 root 2, then you would end up with an answer of sine theta, and it will be root 2 over 8. So any of those two answers would be absolutely fine. It all depends on which exact value of trig you have used. Moving on to question 19, it says write 6x squared minus 24x plus 17 in the form of completing the square. Now for this, what we need to do is take 6 out as a factor. So I take 6 out, in which I end up with x squared minus, take 6 out of 24, that's going to give me 4x, and that's plus 17 over 6. Now from this, we can then use complete square for the square brackets. So I end up with x minus 2 squared plus 17 over 6 minus 4. And again, try not to forget the 6. And then I want to simplify this, so I can write 4 as, let's just write this again, as, and that's going to be 24 over 6. And let's put the 6 there, and then neatening the two fractions here, we've got 6, oh, don't know why I'm trying to write in a highlighter, I end up with 6 x minus 2 squared. 17 take away 24 is going to give me an answer of 7, so it's minus 7 over 6, and then if I multiply everything by 6, I end up with 6 x minus 2 squared minus 7, and there is my final answer for that. Now moving on to question 20, it says the curve y equals x to the power 4 minus 18x squared has 3 stationary points. Work out the coordinates of the 3 stationary points and determine their nature. So first things first, what we need to state is that at the stationary point, dy over dx equals 0. So here we can then work out what dy over dx is, and that's going to be 4x cubed minus 36x. And if we then make that equal to 0, we can then think to factorize, so that then becomes 4x x squared minus 9 equals 0. Now from this, you should be able to spot that this is a difference of two squares. So that's a dot. So what we end up with is 4x x plus 3 x minus 3 equals 0. And then working out the values of x where it equals 0, x either equals 0 or 3 or minus 3. Now from this, what we then want to do is establish what the y ordinates are. So when x equals 0, y equals, now all we need to do is substitute these three numbers of x into our original equation, which is this. So you do 0 to the power of 4 plus or minus 18 0, and it was squared if I'm not mistaken yet. And so when x is 0, y equals 0, so the coordinate is 0 0. When x equals 3, y is going to equal minus 81, so another coordinate is 3 minus 81. And when x equals minus 3, y is going to equal minus 81, and so we get minus 3 minus 81. So there are three coordinates. Now all that's left for me to then do is to state the nature of those. Now to find the nature, what we need to do is find the second derivative. And so when we work out the second derivative and we substitute x value in, if it's less than 0, it's a maximum. If it's greater than 0, it's a minimum. And if it's equal to 0, it's a point of inflection. So that should be an I, not an E. So what we need to then do is find the second derivative. So second derivative is, we know that dy over dx is 4x cubed minus 36x. So the second derivative is going to be 12x squared minus 36. So when when we substitute that into this, we get, so dy over, so from this, the second derivative, when we substitute x equals 0, is going to give us a value of a number that is less than 0, so that's going to be a minimum point, a maximum point rather. So let me just correct that. So it's a maximum for when dy, the second derivative, and we substitute x equals 3, we get a positive value. So that's going to be a minimum. And when we substitute the negative value, we get a value that is positive, so that's also going to be a minimum. So all that's left for us to do is then to complete this so it's a lot neater in the answers box. So here we've got 0 0, which is a maximum point. We've got 3 minus 81, which is a minimum point, and we've got minus 3 minus 81, which is also a minimum point. And there we go. Now moving on to our last question, it says show that 4 cos squared x plus 3 sine squared x minus 4 all divided by cos squared x equals minus tan squared x. Now for this we're going to need to use our trig identities. So let's first of all write down what they are. So what we know is we know that cos squared x equals 1 minus sine squared x. We've got sine squared x equals 1 minus cos squared x, and we know that tan squared x is equal to sine squared x over cos squared x. So this is what we know. Now what we need to do is we need to take one side, so we take the most complicated side. So taking the left hand side, we've got 4 cos squared x plus 3 sine squared x minus 4, all divided by cos squared x. Now from this, what we can then do is we can what we want to try and do is, because we've got tan squared x, what we want to try and do is get sine squared x at the top. So what I'm going to do is I'm going to try and work with replacing this. So if I just put a bracket around the cos squared x, I can write this as 4 lots of 1 minus sine squared x plus 3 sine squared x minus 4, all divided by cos squared x. Multiplying out the bracket, we get 4 minus sine, 4 sine squared x rather, and that's going to be plus 3 sine squared x minus 4, all divided by cos squared x. Then if I simplify these two things here, and 4 take away 4 is 0, I end up with minus sine squared x divided by cos squared x, which equals tan squared minus tan squared x, which is what they wanted me to show. And there we go.